Hey everybody, Mr. Patterson here again, taking a look at section 1.3 now, describing quantitative data with numbers. This is the last section in chapter 1, and it will kind of put together everything that the chapter was all about. So we're going to be talking about analyzing data numerically. So previous section we talked about looking at it graphically. Now we're going to take the next step. So we're going to talk about measures of center and spread. We're going to talk about how to interpret those values. We'll talk about how to quantify if points are outliers or not, and talk about box plots, and then finally putting it all together, making sure that we understand how to use appropriate graphs and numerical summaries to compare distributions. Like I said many times before, very common question on the AP stat exam. So everyone knows what the mean is. You add up all the values and divide by the number of values that you have. The symbol here pronounced X bar, that's new for us, so make sure we start using X bar for the mean. And that's the formula for how to find it, but again, everybody knows that, and you can also get it from the calculator, as we'll see later on. So here's our symbol. So we can write it in form right here as we see, or we can use this sigma notation, which means summing up all the x's and then divide by n. Median, most people are aware of that as well, is just the middle term. So how do we find it? Well, first you have to put all the data points in order from smallest to largest. And then you have two different scenarios. If you have an odd data set, odd number of data points, then the median is going to be the exact value in the middle. We have half the observations below and half above. Sometimes, however, the data set is even. You have an even number of terms, and then the median is going to be the average of the two middle terms. So you just have to look and see which scenario fits your data. So if we look at this data here, which is the 20 randomly selected New York workers and their commuting times, clearly the data is not in order to start, but we can find the mean just by adding them up and dividing by 20, which is the number of terms. If we wanted to find the median, we'd be better served by putting them in order, and we can make a stem plot here to help us out with that. Now when we make that stem plot, we have 20 data points, which means that that's an even number, so the median is not going to be a singular value, but rather it's going to be between two values. And if I count it off, it's going to be between this 0 and this 5. So that means that the median is going to be 22.5 because that's the average, or halfway between 20 and 25. And if you're not sure, you can count them up. Yes, in fact, there are 10 data points below, including that 0, and there are 10 data points above, including that 5. Now, that's measuring center. Measuring spread, there's two different numbers that we can use for that. First is the interquartile range. Now, it kind of helps us to understand the median and how to find that to make sure that we can understand what the interquartile range. First of all, the interquartile range is the range of the middle 50% of the data, and if you ever asked to interpret the IQR, that's what you should give there. How do we find the IQR? Well, before we can do that, we have to find the quartiles. Quartiles sounds like quarters, divides the data up into quarters, 25% in each area there. So how do we find it? Well, just like the median, you put them in order, and then you find the median. And then the first quartile is going to be the median of the lower half, and the third quartile is going to be the median of the upper half. And then all you have to do is subtract those quartiles, Q3 minus Q1. And it's important to understand spread because sometimes two data sets could have the same mean, but drastically different spreads, and it's important for us to be able to understand that those distributions are in fact different. So here's that same example we were looking at before. Put the data points in order, and as we saw before, between the 20 and 25 was the median. That means the lower half is everything with this 20 and less. And if we look at it there, the median of the lower half is going to be between the 15 and the 15. How do I know that? Well, because there are 10 data points in the lower half, so the median of the lower half is going to be between the 5th and the 6th. Similarly, in the upper half, the Q3 is going to be between the 40 and the 45, because again, 5 below, 5 above. Median 22.5, Q1 15, Q3 42.5. We averaged them. So we can quickly and easily find the IQR by subtracting Q3 minus Q1 and getting 27.5 minutes. Keeping in mind that the IQR takes the same units as the actual data. And it's imperative that we keep the units with our data as we go through. So again, interpreting, The range of the middle half of travel times for New Yorkers in this sample is 27.5 minutes. So that's the interpretation. Identifying outliers. All right, so in the past, we've just kind of said, oh, that point's really far away. It could be an outlier. But now we're going to talk about this 1.5 times the IQR rule for outliers. And basically, it's going to help us identify if I have a point that's really, 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 really far away, is it in fact an outlier, or is it just pretty far away? So what do? We are going to take the data that we have, and we're going to find the IQR and multiply it by 1.5. Then we're going to add it to the third quartile, subtract it from the first quartile, and that creates for us these fences, lower fence and upper fence. And if we have a data point that's beyond those fences, then it's referred to as an outlier. Now in our travel time example, the IQR was 27.5 minutes. We just found that. If I multiply that by 1.5, I get 41.25 minutes. Now I'm going to subtract it from the first quartile, which was 15, and get negative 26.25 minutes. Clearly, that lower fence is going to be well beyond any data point that we have, because we can't have negative travel times. It doesn't make sense. Checking it on the high side, I add the 1.5 times IQR to the Q3, 42.5, and I get 83.75. And that tells us that anything less than negative 26.25 minutes or greater than 83.75 minutes is considered an outlier. And if we looked at our data set again, obviously, like we said, nothing on the low side, but we did have an 85. And 85 is bigger than 83.75, so we can say, therefore, 85 minutes is an outlier. All right. Now, the five-number summary. Five-number summary is a quick and easy way for us to get a good understanding of the distribution. And it helps us to make a box plot, which we'll see in just a minute. So the five-number summary is very simply just 5 numbers that represent the data, and it kind of represents it pretty well. Those 5 numbers are the minimum, the Q1, the median, the Q3, and the maximum. Notice these are like actual minimum and maximum. We're not going to just say the minimum and maximum that are not outliers. So why is this helpful? Because the median gives us an idea of center. Having the Q1 and Q3 in this will be able to help us understand what the IQR is going to be, and the minimum and the maximum will tell us a little bit about what the range is. And we could also use this, as we'll see later on, to identify shape pretty easily as well. So the 5-number summary really does a good job of explaining a lot about the distribution. But like I said, we're going to use the 5-number summary to make a box plot. So how do we do it? Well, the first thing we do is we draw a box around the quartiles. Then we're going to make a line in the middle, a vertical line that marks the median. And then we're going to do these lines or whiskers that extending out from the box to the smallest and largest values that are not outliers. And then any outliers you have, you're going to mark them with an asterisk. Now, again, back to our data about travel times. Here they are in order. We have our 5-number summary, median, Q1, Q3, minimum and maximum. And then we're going to take the quartiles, 15 and 42.5. And on our number line, notice the scale, notice it's labeled. On our number line, we're going to make a box around the quartiles. So this one's at 15, this one's at 42.5, and there's that vertical line for the median. And remember, on the low side, we didn't have any outliers, so we can go all the way out to 5 minutes. But on the high side, we did have an outlier, right? So low side, we go all the way out. But on the high side, we're going to go out to that 83. Well, actually, we're not going to go out to 83.75. 83.75 was the upper fence. But our box plot only goes up to the highest value that's not an outlier, which happens to be 65. And then we're going to put a separate point out there, noted with something, a circle, an asterisk, an X, it doesn't really matter, to represent that outlier there. Now, it's good to take a moment here to think about the shape of this distribution, because box plots can help us with that. And basically what we're saying is, where is most of the data? And we can determine where most of the data is by how small or how narrow or how wide these boxes are, or these whiskers are. So on the low side, this box here from the Q1 to the median is much smaller than the box representing the median to Q3. Same thing with the lower whisker compared to the upper whisker. So this data set clearly has more data points on the low side, leading us to understand that this distribution is skewed right. Now, the final thing we need to talk about as far as a numerical measure is another measure of spread, and that's the standard deviation. Now, standard deviation is in the definition, it's like the typical distance or typical deviation from the mean. We can't quite call it the average deviation from the mean because it's not exactly that, as we'll understand as we go on. All right. So when we look at this here, this is data down here on the number of pets for 9 children. And if we look at it here, clearly the largest observation is 4, where we have 3 students with that. But the rest of the data points are kind of spread out, right? Some people only have 1 pet. This person out here has 9 pets. So we kind of want to have an understanding of how this data is spread out. Standard deviation can do that for us. How do we do so? Well, first we have to calculate the mean, because the standard deviation is based on the mean, because it's the average deviation from the mean. And then we calculate each deviation. The deviation that we're referring to is how far apart is our observation from the mean. So observation minus the mean. So the mean for this data set is 5. So if I looked at the first value here, 1, I have a deviation of 1 minus 5, or negative 4. If I looked at this data point here of 8, its deviation, 8 minus 5, is 3. Now what we do with that, okay, we have to take each one of those values and find their deviation. Now the problem is some of them are positive and some of them are negative. So if I added them up, they would all cancel out to 0. So to counteract that, what we do is we square the deviation, and then we average them up. All right, so we square those deviations, and then we're going to average them up. Averaging them up means we're going to divide by n minus 1. Why n minus 1? That's a conversation really for later on, but for now, we just know that it's a sample that we're looking at, so therefore we're going to have more variability. Now, when we just look at that value, meaning the sum of all the deviations squared divided by n minus 1, that's called the variance. Variance is a measure of spread, but the more typical one we use is standard deviation. And to get the standard deviation, we just square root the variance. And that is the more typical measure of spread that we're going to use. We use standard deviation more than variance. And in this case, we end up getting a standard deviation of 2.55. Most of the time when you guys are calculating standard deviation, you'll be getting it from the calculator. So don't worry so much about understanding how to use that formula. You won't see it too often. This is the definition that we just got down, that I just said, and now you can get it down here. So standard deviation, S sub x, that's our notation that we use, measures the average distance of the observations from their mean. And we calculate it by finding an average of the squared distances and then taking the square root. That's called, before we square root it, that's called the variance. So it's the variance is S squared sub x of all the deviations squared, added up, divided by n minus 1. Or you could take this notation here. There's that summation, the sigma again, sum of all the x minus x bars squared, and then they're showing it here times 1 over n minus 1. But really, it's just pulled out like that so it doesn't confuse you with the sigma notation there. And if you wanted the standard deviation, you just square root it. Now that we understand what all of the measures of center and spread are, now we need to make sure we understand when to use which. So basically, you're coming to this analysis here. Am I going to use the mean and standard deviation for the center and spread, or am I going to use the median and the IQR? And this is a conversation about shape and whether there are or are not outliers. If we have outliers or skewness, the mean and the standard deviation are going to be affected by that. We say they are not resistant to outliers or skewness. So if we have a skewed distribution or a distribution with outliers, then we should use the median and the IQR to describe the shape, describe the center and the spread. If we do not have skewness, meaning it's roughly symmetric, and there's no outliers, then you can use the mean and the standard deviation, because those are fine, right? But if we have the skewed data, the mean is going to be pulled towards where that skewness is. So if it's a very skewed distribution, the mean is going to be higher. If we have a high outlier, the mean is going to be higher, right? And therefore, the standard deviation is going to be affected as well, because the standard deviation is based on the mean. If you want to make sure that you use the correct measures, always start with a plot. What plot you use, box plot, histogram, excuse me, stem plot, anything works, just get it done.
Reminder that the TLC meeting will be taking place in D like David, 103. Again, the TLC meeting will be taking place in D like David, 103.
Sorry about that. Now we just want to kind of summarize everything, and this is just a bigger picture kind of thing, organizing a statistical problem. Not something that we're going to be using here in this chapter, but if we're trying to organize a problem, we want to say, okay, what is the question that we're trying to answer? Then we're going to talk about how are we going to collect that data? How are we going to, who are we going to select to be part of our study? Once we get the data, then we're going to make graphs and carry out needed calculations, and then we'll give a conclusion. Now, for right now, again, thinking bigger picture, we're in the do step, right? We're making the graphs and we're coming up with the numerical summaries. As we go throughout the course, we'll kind of start to fill in the rest of the pieces of this puzzle. So take a moment to look at these objectives here and make sure they all make sense to you. If there's anything that's a little bit confusing, come see me or read the textbook. Have a good day, and we'll see you next time.